Bismillahirrahmanirrahim. In the name of God, who is the most beneficent and merciful. I am Amjad Ali Shah, lecturer in philosophy, Department of Islamic and Pakistan Studies, Cohort University of Science and Technology. So students, our course title is Introduction to Logic. The course code is PHI102. Our lecture number is 17. And our today's topic of discussion is checking validity and invalidity by means of Venn diagram technique. Now, we have already discussed in the previous lecture about this technique, but today we will focus on the technique which is about the particular proposition. And let's move to the second slide. Now, these are the outlines of today's lecture: Venn diagram techniques, checking validity and invalidity of syllogism containing both particular and universal propositions. Students, if you remember in the previous lecture, we discussed the method, the technique of checking the validity or invalidity of syllogisms. That's categorical syllogism, but in those categorical syllogism, there were universal propositions. Now, in this lecture, our main focus will be on the method that is about the particular proposition, or in other words, we can say there are some syllogisms which contain both particular and universal propositions. The outcome of this lecture is definitely to know about the method, the technique, that how to know about the validity and invalidity of syllogism by a diagrammatic technique. Now, here we have an argument that is I2. This is the form of the argument, and the argument says some philosophers are mathematicians, some scientists are mathematicians, therefore some scientists are philosophers. Now, in this argument, all the propositions are particular affirmative, and that's why it is I2. So some P is M, so it means we have already discussed about this process, how some P is M is equal to Pm is not equal to 0. How it is diagrammatically represented. In the previous lecture, we had a great deal of discussion about this method. So sum S is M, Sm is not equal to 0. Therefore, sum S is P, Sp is not equal to 0. Now, this argument is actually in standard form. By standard form, we mean when the major premise appears first, then the minor premise, and then the conclusion. Now, this is the diagram. Now, this is the symbolic form. Sum P is M, Pm is not equal to 0, which means that we will put X in the clause of Pm. Sum S is M, sum Sm is not equal to 0. This clause is not empty. There are some members which are denoted by X, and there sum S is P, Sp is not equal to 0. Now, what does the first premise say? The first premise says Pm is equal to 0, is not equal to 0, sorry. Now, you're supposed to put an X in the clause of Pm, in the area of Pm. So, where is the area of Pm? This is Pm and this is Pm. Now, students, remember it, you're not supposed to put X over here, because if you put X over here, so this clause is left, and this is, I would call it a diagrammatic biasness. And you cannot put X over here also. So the best way to decide whether putting an X over here or over here, if we put it over here, that would be really unjustified, or on this part of the area. so it would be again unjustified. So the better solution is to put x on the line, because the line is shared by both of the PM clauses. This is a PM clause and this is PM clause. Now the second premise says Sm is not equal to 0. Now this is Sm and this is Sm. Again, we will have to put x on the line. So student, remember, whenever x is on the line, so the argument is actually invalid. But how it is invalid? If you look for the conclusion, that is Sp is not equal to 0. So the conclusion say that Sp, the clause of Sp should have an x. Now this is Sp, but in this clause there is no x. It is actually on the line. Neither here is an x nor over here. So we don't find the conclusion. So it means that these premises do not support the conclusion. That's why I2 is invalid. Next, this is another argument. Though we have used the same terms, but the form is different. Some m is not p. Some s is not m. Some s is not p. This is O1. So some m is not p. MP bar is not equal to 0. Some s is not m. Sm bar is not equal to 0. Some s is not p. Sp bar is not equal to 0. Now we have this. We have converted it, the syllogism, from the ordinary language into a symbolic form. In a symbolic language, some m is not p, mp bar is not equal to 0, some s is not m, sm bar is not equal to 0, therefore some s is not p, sp bar is not equal to 0. Again, the first premise says mp bar is not equal to 0. Now we will have to put an x in the clause of mp bar. Now we have mp bar and mp bar. So neither we can put x over here nor over here. So because if we put over here, it would be an unjustified decision. So better to put the x on the line. The second premise says Sm bar is not equal to 0. This is Sm bar and this is Sm bar. Again, we will have to put x on the line. And if you look for the conclusion, you will not find the conclusion. It is invalid. As I mentioned it earlier, that whenever x appears on the line, so the argument is basically invalid. So Sp bar is not equal to 0. So this is Sp bar and this is Sp bar. So this x is actually on the line. It is not. If it would have been present inside this clause, then we would definitely consider this argument as a valid one, but now it is invalid. Next it is we have 0002. Some philosophers are not mathematicians, some scientists are not mathematicians, therefore some scientists are not philosophers. Now some p is not m, pm bar is not equal to 0. Same is the case with this one, as you know about this whole process. Now let's check it by means of Venn diagram technique. Now the first premise says PM bar is not equal to 0. And the second premise says SM bar is not equal to 0. Students, again, you must remember that you are not supposed to diagram the conclusion. Only we diagram the premises and then we look for the conclusion. If it is found, the conclusion is found after diagramming the premises, then we say that it's valid. Now PM bar is equal to 0. This is PM bar and this is PM bar. So we will have to put x on the line. And SM bar is not equal to 0. Sorry, SM bar is not equal to 0. PM bar is not equal to 0. We put x over here, and SM bar is not equal to 0. we put x over here. So the conclusion says SP bar is not equal to 0. So this is SP bar and this is SP bar. So x is not present in both of the clauses inside these clauses, this one and this one. So that's why 002 is also invalid. Next, now this is another syllogism, which is in which there are some particular propositions and a universal proposition as well, that is universal affirmative A002. All criminals are parasites. Some neurotics are not parasites, therefore some neurotics are not criminals. Now, so all PM bar is equal to 0. So you can check, if you have a problem, you can check the previous lecture, because I have shown diagrammatic representation of all 4 categorical propositions and about that possible situation, about combination about middle term and major term and minor term and middle term with different position, with the changing position of the middle term. So we have a diagram. PM bar is equal to 0. Now here we are supposed to shade the area of PM bar. This is PM bar and this is PM bar. I have already shaded it. SM bar is not equal to 0. Now this is SM bar and the one that is shaded. So students, remember the area which is shaded, now it will not be counted. Now we will not put x on the line because it is shaded, it has been made empty. Now we have only SM bar, this clause left, so the only choice to put an x is that inside this clause. So we have already put it. So the conclusion says sum S is not P. SP bar is not equal to 0, which means that there should be x in the clause of SP bar. Now we have SP bar and SP bar. So here we have an x, but in particular proposition, because our conclusion is actually a particular proposition, that is particular negative. In particular proposition, if x is present on either of the clause, so it is considered as valid. But in universal proposition, if suppose if this would have been a universal, this is shaded and this is unshaded, so we would consider it invalid. But in particular, it is not the case. In particular, if x is present on any of the one of the clause, still it is considered as valid. So our argument is valid. Next, we have another syllogism, that is IAI3. Some reformers are fanatics. All reformers are idealists. Therefore, some idealists are fanatics. Now, if you see this proposition, syllogism, this is a combination of universal affirmative and particular affirmative. But this is a little bit different from the previous one. So students, there is a rule there is a rule about this technique, and the rule says in categorical syllogism, if one premise is particular and the other one is universal, then the universal premise should be diagrammed first. So it means that we are not supposed to diagram I first, but rather we are supposed to diagram the universal affirmative, that is A, first, and later on the I proposition. Now let me violate this rule. What happens? Now As far as the rule is concerned, the rule says that the universal premise should be diagrammed first, this one, and the particular premise should be diagrammed later on. Now, for a while I violate this rule. Now, the first premise says MP is not equal to 0. So we have a clause of MP and we have another clause of MP. So definitely we will have to put it over here. So on the line. Now if I diagram the second premise, MS bar is equal to 0. That is MS, this one is MS bar, this one is MS bar. Now I have diagrammed it, shaded it. As far as the conclusion is concerned, now we look for the conclusion after diagramming the premises. SP is not equal to 0. The conclusion says that there should be X present in the clause of SP. Now we have SP, we have SP. There is no X present in either clauses of SP. So it seems to be invalid, but in fact it is not invalid because we have already violated the rule. Now let's abide the rule now. So the rule says that this universal premise should be diagrammed first. MS bar is equal to 0. This is MS bar and this is MS bar. If I diagram this first, I have shaded it. Now let's move to the second premise. This one is the second premise. As a matter of fact, according to the rule, MP is not equal to 0. Now this MP has already been shaded, so it has, this class has been made empty, so we will not bother about this. So we have MP is not equal to 0. We have MP, this is M bar P, this is MP bar, this is M bar P bar. So we are left only with this choice. So we put X inside this clause. Now what does the conclusion say? The conclusion say SP is not equal to 0, which means that there should be X present in the clause of SP. Now we have SP, SP, so if X is present in either of the classes of SP, so the argument is considered as a valid one. Now, apart from ordinary language, suppose if I say check the validity of the syllogism EIO3, this is the form. So any argument with different terms, middle and minor and major term, could be in this form. But in the symbolic form, it would be like this. The same, the form is the same. No M is P, MP is equal to 0, some M is S, MS is not equal to 0, therefore some S is not P, SP bar is not equal to 0. So E, MP is equal to 0, this is MP and this is MP, we have shaded it. MS is not equal to 0, this is MS, so it has been already shaded, so it has been made empty, so we are left only with this. MS is not equal to 0, this MS, we are left only with this MS, so we put X over here, and the conclusion say SP bar is not equal to 0, that there should be X present in the clause of SP bar. Now we see SP bar, we see X in the clause of SP bar. This is also the clause of SP bar. If it's present in either of the clause, still it is considered as valid. So EIO3 is valid. Now let's check the validity of EIO4. This is in a symbolic form, this argument. So a type of argument in which the middle term is in the position, the position of the middle term is the fourth figure. So it may be any argument with any different types of terms. No P is M, some M is S, therefore some S is not P, SP bar is not equal to 0, MS is not equal to 0, PM is equal to 0. Now PM is equal to 0, the first premise says PM is equal to 0, so we have shaded it. The second premise says MS is not equal to 0, one MS has been already shaded, so it has been made empty, so it should not be counted as a class now because it has been already made empty. ms is not equal to 0. So this is ms, this is m bar s, this is m bar s, this is m s bar. So only this ms is left, so we will have to put x over here. Now what does the conclusion say? The conclusion say sp bar is not equal to 0. That there should be x in the class of sp bar. If x is present, so we will consider this argument as a valid one. Now let's see. This is sp bar. Here is no x present, and this is sp bar. So x is present inside this class. So our argument is valid. So student, as far as syllogisms are concerned, so we are done with both type of techniques, that is about the universal propositions and the particular as well, and the combination of both universal and particular proposition, those syllogism which contain both universal and particular propositions. So student, as I mentioned in the very beginning of this chapter, that there are 256 forms of syllogism. So only 15 forms of syllogism are valid. It means that only 15 forms of syllogisms are consistent logically. All other forms are inconsistent. So, and those forms, the detail of those 15 forms has been given in the course book, that is Introduction to Logic by M. Copy. Now, these are the references. Some of the examples have been taken from A Concise Introduction to Logic by Patrick Hurley, An Introduction to Logic by Irving M. Copy, Carl Cohen, Kenneth McMahon. The edition is 14th, Pearson Education Limited, 2014. So thank you very much indeed.